All right, so you probably can tell from my amazing accent, I'm not from here. I'm from the United States of America, from Virginia, in fact. Any other fellow countrymen in the room? Americans? No? That's what I thought. Did you see that big boat outside? That was my countrymen. Actually, fun fact, so the Gerald Ford is from Norfolk, Virginia, which is where I'm from. It's like 20 minutes down the street. It's crazy our schedules got collided like that. So yeah, that's a very big boat, and they built it all like right down the street from where we live, and commissioned it, and now it's the flagship of the United States Navy. And I don't want to tell you how much money we spend on military. It's way too much. No, we could put to better things like healthcare, taking care of people. We don't do any of that. I know that would get a laugh in every country other than America. Every American country or city would go, yeah, you're right. There would be no laughter. Let's see. Who's first NDC Oslo? Hands. That's a good number. All right. Is my first as well? I've done NDC London a handful of times. First Oslo. I love to do other NDCs. So what do I usually ask here? It's hard to ask questions here like, who came the farthest? Did anyone come from a country not in Europe? All right, that narrows it down. I had a gentleman, when I did this talk in London, he rose his hand and he said, I'm from South Africa. I'm like, wow, that's a long way to travel for one conference. He's like, no, I live here. I'm like, you misunderstood the point of the question, sir. All right, so, well, I don't know all the European countries because I haven't taken world geography in 20, 35 years. It's been a long time. All right, so no one outside of Europe? All right, well, that kind of narrows it down. Who's been to every NDC Oslo? I actually don't know how many there have been, so that's a trick question. All right, so no hands went up. Who's been to 2 NDC Oslos? 3, 4, 5, 6, 7. Oh, I have one hand in the back. How many? 9, 10? All right. Good job for you, sir. I think coming out to the conferences, like this is amazing. We don't get this sort of turnout to anything in the States anymore. Like everyone is kind of holed up. They work from home. They don't want to go out and talk to people. Like walking into this expo hall, everyone who's never been to an NDC Oslo, you walk into that room for the first time, like it's kind of overwhelming, isn't it? Just the sheer amount of people. And I walked in at a keynote, and it's like just too many people. I was ready to turn around and walk out because it was just overwhelming. But I am super glad to be here. Thank you to the NDC team for inviting me, and hopefully I can come back in the future. As long as y'all don't put red in the box, maybe I can come back. So let's make an agreement now. Green. Green. Thank you. All right. Well, let's go again. Get started. Yeah, it's right at time. We might as well get started. I have this fascination with conferences this big because you all come here and you get to see all these amazing speakers. And they're up presenting to you, and they're doing the hard work, quote, hard work. But the thing is, we're hardly working at all. I show up for an hour if I have one session, 2 hours if I have 2 sessions. And I do a little spiel. You all learn something new, hopefully. And then you go on, you go to the next person, hopefully learn something new. But I'm not working at all. I'm just showing up, putting on a smiling face, and I'm presenting. The people doing the real work are like the gentleman over here doing sound and video. He's doing all this amazing work to make me look good and hopefully sound good as well. And there's folks in every other room doing this work. There's folks running the overload room, whatever it's called. There's folks down emptying the trash every single hour. There's folks making sure that you have food to eat all the time and making sure it's always good. That poor coffee person has to deal with a line 30, 40, 50 people long every single hour. There's a lot of work happening in the background that I don't think we really appreciate unless we take a step back from it. And that's a very long way of saying, as application developers, Yeah, I have a tie in here, promise. Our applications kind of work the same way. We hopefully build these really pretty user interfaces like this. I didn't build this. Someone else built this because they have talent. And this is pretty. This is what our customers are coming to. This is what our users are coming to. And this does a lot of work, but it's not doing really anything. All it's giving us is a list of a couple items and a place to put in my payment information. I worked on an app similar to this a very long time ago, early in my career, and we had a workflow for the most important button on that screen. Who wants to guess what it was? It's a trick question. It's the only button on the screen. The Pay Now button. So the Pay Now button is critically important. Why? Because it's how we get paid and it's how the customer gets whatever crap they're ordering. So you press the Pay Now button. And this is the way our workflow worked. It would go off and it would do some stuff in the background, create the order, so we could link items to the order, and we would go check our inventory, make sure we had the stuff in stock. There was a process for that. We would charge the credit card, and then we would go off and we would send an email to the person saying, hey, we're all good. We're going to get your stuff shipped out. And come back to the Pay Now button. That would go away. Congratulations. Everything's great. Except when the email goes out. Our SMTP is kind of crazy because it doesn't always work all the time. And our SMTP server had gone down. So if you said pay now, create an order, check our inventory, charge the credit card, send the email would fail. And we would go back to the user and say, hey, there was an error, something wrong, bad happened. And we had already charged the credit card, which you're not really supposed to do unless you have a way of going back to the customer and tell them everything was successful. So there were cases where there were repeat orders, and because the people would come back and go, oh, let me do this all over again. Oh, why did I order this crap 3 times in a row? It's because our SMTP server was down. Yeah, this not good. We shouldn't do it this way. So hi, everyone. I'm Kevin. And if you've never met before, I am the American from the great state of Virginia. I'm an independent consultant, Microsoft MVP. I love building applications in ASP.NET Core, deploying the Microsoft Azure, and really anything web development. So if you have questions about any of those things, I would love to chat with you afterwards. If you want to talk to me at the end, if I'm not here, I have socials here on the screen. I also do a series of courses, actually one that's pertinent to this talk. I have a course called Signal on Mastery, which if you don't get a photo of it now, I'll put it in the Slack for everyone. But I'm giving it to you all for free, so that's actually why you want to get the QR code. If you want to do anything real-time web development, Signal on Mastery is the best course available for learning that sort of stuff. Everything from web development to console, WPF, MAUI apps, Blazor to a degree, and I'll teach you how to build them in real time. I also have a course on HangFire. So we will actually talk about HangFire in this course. And I just released this course not too long ago, so we're slowly building up some students for it, but also free to you all. I'll make sure that information's in the Slack at the very end. All right, let's go back to our scenario. And let's talk about how this process could have been a little bit better. Instead of everything being reliant on the thing happening before it, how could we redesign this to be a little bit more resilient to cases where our email server goes down? Well, let's start with the Pay Now button. Click Pay Now. We go off and we still want to create an order. We want this process to happen. And 2 things occur. First, we go back to the user, tell them, we have created your order. Here's your confirmation. If you've used any modern e-commerce site, this is what it does. Is Amazon a thing over here? I assume so. When you go to Amazon, you order something, you never get a, hey, your order's been shipped immediately. You get an order confirmation. Basically saying, we've received your order. We have no idea if you can pay for it. We have no idea if we have it in stock. We have no idea if we can ship it to you in a timely manner. But here's your order confirmation. At the same time, we go off and we do the other things that we need to do. We check our inventory, we charge our credit card, we send our email. Now, if something happens along the way and we can't charge the credit card. We can then go back to the customer and tell them there was a problem, fix your payment, we'll restart the workflow. If we can't send the email, SMTP typically just comes back up a couple minutes later if there's an issue. So we wait, and then a couple minutes later, we try sending an email again. But that workflow on the right side of the screen is independent from the thing that the customer cares about, is that we have just received the order, and we will deal with everything else a little bit later in the background. So I lost the boom on my thing. Oops, okay. I did this workshop a long time ago where we talked about building production web applications. What does it take to actually take an application production? You go to a conference like this, and you learn a lot of fancy buzzwords, a lot of cool tools, but rarely do they talk about how do you actually ship something and take it in production, and how do you manage it in production. So we did this workshop, and we did this whole 2-3 hour section on background tasks and background workers, and we thought we were just preaching to the choir, and turns out not everyone really understands the various ways, methods, methodologies for deploying background services. So that kind of inspired me to put this talk together, and by the room being full, feels like this is something relevant to everyone potentially. There are two types of background tasks we're going to talk about. The first is on demand. This is the stuff that needs to occur immediately, but not like at the moment I press the button. So it can wait a second, but it needs to happen as quickly as possible. And typically this is going to be some sort of workflow. Examples from what we've done. Transactional emails. This is the important one. Hey, I've received your order. That's an email that needs to go out. I need to charge your credit card, some sort of payment processing. Do I need to go notify other services that something has occurred? If I or notify my own services. Something's occurred in the system. Here, I'm going to send you a hook about it. Any processing. So you put something new in the database. You need to go do some cleanup on it. We do that sort of work kind of on demand. These are called triggered events. We have other types of background tasks that happen on some sort of schedule, and we call them reoccurring tasks. Most likely, it's going to be something that happens, we have all kinds, hourly, minutely, weekly, monthly. I used to work on a system where we had, biannually, so like twice a month, would happen on some sort of rotation. And this is going to be, our biggest one is reports. We want to send a report to our administrators, to our owners, with relevant information that happens on a schedule. My first Azure function that I ever wrote was to clean up resources in an Azure blob because, all right, I'm going to sidetrack for a second. Wrote a thing, puts data into a blob. It's like, oh, it's only a couple hundred kilobytes, not a big deal. We'll deal with that later. Fast forward like 2 years. No one laughs. Okay. A couple hundred kilobytes adds up when you're constantly adding 200 kilobytes at a time. And we got to this point where I'm like, how much stuff is in this blob? I look at it, it's like, oh, it's a terabyte of just text files that we weren't using. It was just redundant data that wasn't necessary anymore. And when you have a terabyte worth of stuff in blob storage, it actually costs a little bit of money. Like, blob storage is fairly free until you put a lot in there. So we wrote a resource cleanup script that would just go through and delete all that work for us. And then Azure just went and added that as an option to blob storage, which was funny. A couple considerations when you're figuring out what type of background service you want to write. First is, where are you going to host it? Because it needs to run somewhere that is going to work. Make sure it's up and running. Really two obvious places. Where, one, you're running it on your local machine. That might be something like a Windows service, which I mention Windows services because I have done this talk enough times where people go, I write Windows services all the time, and it's really relevant what we talk about in here, and they learned a bunch of new stuff. So I didn't think anyone wrote Windows services anymore. Turns out a lot of people do. If you're deploying a thick client application, you might want to run a background service in your thick client. and we'll show you a process for doing that. I'm assuming a lot of people are probably web developers in this room because we kind of take over the world now. But if you're doing web and you're doing web on .NET, you're probably deploying ASP.NET. We can do background work in our ASP.NET Core apps, fairly easy. And then there's this other spectrum where if you're deploying the cloud, you might want to take advantage of cloud services. So we'll talk about Azure Functions and some ways that we can deploy background services there. A couple other things to think about with background services, figuring out what you want to write it in, how you want to deploy it. We talk about resiliency, and that basically means what happens if a task fails. If I have my send email task and SNDP goes down, what happens? What happens if it fails? What happens if the service crashes for any reason? We need to be able to recover from that. And some of the tactics we'll talk about are better than others for dealing with that sort of thing. So I mentioned the word tactics because I think the most commonly used phrase in our industry is "it depends," right? Like, all right, I have a problem. Can I use X to solve it? Well, it depends. Or I need to do X, Y, and Z. All right, well, it depends. Because we have that phrase, "it depends," I want to give you a variety of ways to solve this problem, and you kind of pick and choose and learn from what makes sense to you and your application. So the tactics that we're going to try to cover in the next 50 minutes are .NET hosted services, IHostedService. That'll translate into a quick discussion on Windows services, which is fascinating. If you've ever written a Windows service pre-.NET Core 3, it will blow your mind. We'll transition then into ASP.NET Core hosted services, so if you're deploying an ASP.NET Core app. We'll talk briefly about Quartz, which is a job scheduling app or job scheduling library for .NET, which I've used quite a bit early in my career. It's great for a very specific set of purposes. We'll talk about what those are. We'll talk about HangFire, which I have a course on, which is an amazing tool set if you just need a GUI and something that's really hard to mess up. And then finally, Azure Functions, if you need cloud scale, which I love cloud scale, so we'll talk about that. All right, .NET hosted services. Who is familiar already with IHostedService in .NET? Okay, a couple hands. Good. So we're going to kind of recap what it is, and everyone else, you get to learn. So in .NET, I looked this up. It was .NET Core 2. They introduced this concept called the IHostedService. And the problem that it was trying to solve was before, even in .NET Framework, trying to do any sort of work in the background of a .NET application was very difficult to do. You usually had to hack it together yourself. There were a couple third-party libraries that helped a little bit, but not quite. It was just a difficult job. With .NET Core 2, and soon in .NET Core 3, they introduced this concept of the iHosted service, which allowed us to implement many hosted services inside of our application. I could have one, I could have 10. You can have as many as you want, and these are independently managed services running in the background of your application. The .NET host manages the entire lifecycle of them automatically for you. So when your application starts up, the hosted service starts up. If your application shuts down gracefully, which hopefully yours do, it will shut down the service gracefully, clean up any memory or resources that you have open. If there's a case where the service fails, you can write hooks so it automatically restarts itself. It's a fairly powerful little piece of code. Here's an example of one. This is a class I've written. It implements background service, which implements iHostedService. And what this is going to do is when the application starts, it's going to call the execute async method inside my class, and it's going to go off and do work until that method ever returns. When that method returns, the service is done, it shuts itself down. Now I have a while loop in here that's just going to go forever until the application wants to shut itself down gracefully, and that's done with the cancellation token. But this is really useful. It's just going to go off in the background, it's going to do its own thing, and I have full insight into my .NET application here. So I have dependency injection, if you're using dependency injection, which you probably are. And So you can inject all your services, do all your work, and this is happening gracefully in the background. To tell .NET that this is the thing, you inject it as a service. So in your startup CS file or your program CS, depending on what flavor of .NET you're using nowadays, you have a section somewhere where you configure services, and you add hosted service of whatever type that you create. So cleanup folder service. Now, what's really cool about this is that this IHostedService isn't dependent on being a web app. It's not dependent on being a console app or WPF or MAUI or whatever thing in the .NET universe you're using. It works across all of them if they support iHost, which most of them do. I want to show you Windows Service because I had a use case back in 2012, 2013, where we were building a Windows service on .NET, and this is before .NET Core had really picked itself up. And if you've ever written a Windows service in .NET Framework, there were two ways to do it. There was the hard way, which I did, was you had to write all the hooks for a Windows service yourself manually, which basically means you handle command line arguments. What does /s do? What does /c do? And the documentation for writing that sort of stuff wasn't very good, and you learn most of it from forum posts from 10 years prior. There was also a package out there called Top Shelf, which was amazing, and I didn't learn about it until I had written it all by hand. That's the story of my life. But with .NET Core, or now just .NET, we have this new service called hosting.windows services. So you install this package, and then in your application, it's literally, this is technically one line of code. Use Windows Service. Give it a name, set a couple options on it, and now this will automatically take care of all the Windows Service stuff underneath the scenes. Why don't we do a demo? So I have a code here. This will all be available for you in Slack when we're all done. But this is basically what you just saw here on the slide. We have an application. We're going to set up a Windows service called the Tactical Windows Service. And we're going to use a iHosted service called Cleanup Folder Service. I'm going to say service a lot. And what does the Cleanup Folder Service does? It cleans up a folder. So if we look at the code here, I made a couple of tweaks to this since first time I wrote it. But every couple seconds, it's going to go check a temporary folder and see if there are any files in it. If there are any files in there that are older than 5 seconds, we're going to delete the file. All right, that's it. So go to the command line. We're going to say .NET run. Give it a second. There we go. So this is checking a folder called ctemp. I'm going to go to that folder right now, and I have zoomed it for y'all. And what we're going to do is we're going to add a new folder to it, new file to it. We'll just call it new Word doc, and then we're going to wait a moment for the delay, which I think I set to 15 seconds, but we'll give it a moment. All right. So it found one file to delete, it deleted the folder. Cool. Just doing background work. That's not applause worthy. You all, I say as no one applause. All right. That's not impressive at all. I'm going to show you something that's impressive. So let's take that same application, and I'm going to copy some clip notes real fast. I'm going to scroll down. And we're going to create a Windows service. Now, if you've never created a Windows service before, you open up a new command prompt as administrator, and I'll paste this code, and then I have to then go get the path of my publish. So we'll say .NET publish. So it's currently published to and let's see, it's called tactics.exe. Before I do that, let's open up my services page. We'll scroll down, and you'll see that there's nothing called tactics in here. Yep, nothing called tactics. All the T's. All right, we'll go back. Hopefully I typed that all in correctly. We'll enter success. Success is good. We go back to our services, hit refresh, scroll down. You see the tactic.windows services. Now I have it set to manually start. We'll give that a second. It's now running in the background, doing the same thing that I was doing before. We'll go back to our temp folder. We'll create another file. We'll do a PowerPoint presentation now. And we, again, just wait a couple seconds, anywhere between now and 15 seconds. And the one problem is I don't have the logging inside here. If I cared about logging from my Windows service, I could log to event source so I can get it from Windows directly. But normal file. It's because it was all done by the Windows service. Now that is applause-worthy. Don't give me your pity applause. I saw. All right, I'm going to worry about deleting that later. We're going to shut it off for now. Now, I do that demo. I was going to take this demo out, but I've had at least 3 people come up and go, that was super useful. I didn't know we could do that in .NET. I have a use for that tomorrow. If you're that boring too, awesome. I'm glad I could help. Let's move on to the next thing. Actually, a couple of pros and cons of Windows services. First, they're really easy to build. If you've ever built a Windows service in .NET Framework, compare that to this, it's a night and day difference. Windows will automatically manage the lifecycle for you. So if your Windows, this is the nice thing about Windows services. If your Windows service crashes, the service scheduler is going to automatically turn it back on. And if it constantly keeps crashing, you can go into the error log and see what the problem might be. This is useful. The con is it's limited to the machine or the server that you're running it on. So if you're scaling this at any capacity, you're responsible for setting up those Windows services. This is useful for, well, it's not really useful for on-demand work. This is probably a little bit better for scheduled work that's going to happen, or if you're watching folders, or if you're watching any sort of external stimulus to execute the action. If you're trying to do work on demand, you have to do all the heavy lifting. It's not very done for you. You're also responsible for resiliency of individual tasks. So if my task for cleaning up the folders has an issue in it and it fails, it's my responsibility to go put a try-catch around it or to do some sort of other work. Common question I get is, Kevin, that's great if I'm running on Windows, but what if I'm running on Linux? Turns out there's the exact same thing for Linux. So if you can run under systemd, you can install the systemd package. You change the line that says use Windows services to use systemd. Ta-da, it should work. I have not actually tested it yet. I've just put the slide in here. But everything I'm told says one line of code change. After you add this package, it should work on Linux as well. So, cool. Let's transition away from Windows services into ASP.NET Core apps. Who's an ASP.NET Core developer? All right, that's what I like to see. All right, ASP.NET Core. We can take the exact same background services, IHostedService, and we can bring it over to our application. So this is a .NET 7 app using that new funky single file syntax that they all like. Does anyone like that? Single file? The one hand? Does it confuse the rest of you? You're like, give me my classes. I just want my classes. Where's my program CS? All right, doesn't matter. We still are using an iHost, so it's an iWeb host. And I am implementing AddHostedService, my cleanup temp folder service. And it does the exact same thing. When the application starts, the hosted service automatically starts, does its thing until the application crashes or shuts down gracefully. Let's show that as a demo. The exact same app. This time it's ASP.NET Core. And you can see here, I have my map kit that said hello world. I've taken the exact same background service that we had in the previous example. Yes, exact same. Should be the exact same code. And I'm adding it as a hosted service for ASP.NET Core. So now, if I go in, say .NET run, if I spell it correctly, and we wait a moment so we can tell we're running ASP.NET Core because I can open a browser, and it says hello world, yay. But in the background, the little watcher is running, and it's waiting for some files to get added. Oh, my temp folder is in a different place. That's the one thing I changed, just to show I'm not reusing services. I'm going to add a new file. I'll just add a text file this time, and we'll sit here and wait. All right, just ran, deleted the folder or the file. File's gone. Yeah, cool. The impressive part isn't that I delete the file. The impressive part is I just reused the code that I written originally. So if I'm writing a lot of these services, I can share them across multiple applications if I need to, if I have a case where that's required. Now, we talk so much about reusability in our code. This is actual reusability. I can use it everywhere. But I think it's super useful. Doesn't solve one or two core problems. Big pro, go again, easy to build. Runs inside of our ASP.NET Core application. Yay, everyone's happy. Automatically starts when the application starts up. Cool. There's a couple fundamental cons. We can't really do anything with scheduling here. This is the same problem that we had when it was a Windows service. If I was scheduling any sort of task that needed to happen, I had to write that scheduling myself. Let me check the time every iteration of the while loop, or I could set up my own timers. There's various ways I could solve that problem. I actually want to show you Quartz in a moment, which solves that problem a little bit easier, better, in my opinion. Again, you're responsible for resiliency. If that hosted service crashes for any reason, it just stops. You have to restart it some other way. So it's up to you to do a little bit more of the heavy lifting. They're giving you the framework to build the services on. All right, let's move on to Quartz. Now, who's never heard of Quartz before? All right, that's the number of hands I was expecting. That's a good number. So Quartz is this really cool service for setting up. We have jobs and we have triggers. And if you need high precision timing and scheduling of different jobs in your application, Quartz works really well here. And it works, again, across any type of .NET application you might want to run. The only drawback is it's a lot of code to just implement something simple, in my opinion. If you look at the code on the left, we're creating two concepts. First, we have the job. This is the work that we want to do. And so I'm creating a job called cleanup temp folder job. And I'm setting some other parameters like I want to store it durably, so I want to keep track of when it runs. I want to make sure that it doesn't run twice in a row at the same time. And then I'm adding a description to it. So the job is separate. The job will run whenever I tell it it is supposed to run. That could be on demand. That could be on some sort of schedule. So the snippet below it, I'm setting up a cron task. Every 30 seconds, I want to go run that job and make sure it runs on a reoccurring schedule. Since I'm running this inside of ASP.NET Core, I also have to add the bit on the right for adding the Quartz server. This also gives me a little bit of dependency injection as well. Still a pain in the butt to set up. But when it runs gloriously. This is what a Quartz job looks like. You have to implement their iJob. You can't just use your own code or use anything that Microsoft's written. So you're vendor locking a little bit to Quartz when you go this route. But you can get dependency injection, and you fill in the blank with the execute method. When this job runs for any reason, let's go do some stuff. So I take the same concept that we talked about before. I had to rewrite it because it's its own implementation. So we'll show you program first. This is the snippet I just had on the screen. We'll create the job, and we'll create the trigger. So every 15 seconds. we're going to go run Quartz. Now, I have a separate service for Quartz server. What's really cool here is if I'm backing this as some sort of data store, like Redis or SQL Server or you name it, I could have my web server and my job server separate. So the web server can issue tasks that need to be done, and the job server does them as they come in or as they need to get run. This is really nice because it doesn't bog down your web server. This is the con that I should have put into the ASP.NET Core slide. If I have 15 hosted services running inside of my ASP.NET Core app, well, that's going to take some resources away from my ASP.NET Core app. So if I'm going for massive number of requests per second, that might be slightly limited by if I have a lot of heavy lifting hosted services. If I have a separate job server that's doing all this work, I don't have to worry about that. My web server can just be a web server. My Quartz server can just be a job server. The cleanup temp folder, similar, but like I said, you have to implement iJob, their implementation, and you have to use their interface. So I'm executing the job when it occurs, going to a directory, getting files, and deleting the files as I see them. Bless you. If I go to .NET Run, so this is my web app with Quartz. All right, so this is running. This is looking at cleanup temp folder service again. Yep. I'm going to create another file. We'll create an access database. No, we won't, because I don't want to actually run. No one willingly opens access anymore. All right, let's create a Word doc. Here we go. So we'll let that sit there for a minute. What did I say, 15 seconds? So I'm going to wait about 15 seconds. The Quartz job is going to execute, and it should delete that file. Boom, everything's good. So you're probably going to do like way more complicated stuff with these systems than I am, but I have written this code before to just go clean up a folder, go clean up a resource, because you might accidentally put a terabyte worth of stuff in there and forget about it. Let's close that out. So moving along, big pro of Quartz is you get very precise scheduling and timing. So if I tell that job I need it to run every half hour on half hour, it's going to run every half hour. If I need it to run at 9 in the evening every Sunday night, it's going to run at 9 p.m. every Sunday night. Or what is that translated to your time? 2100? Yeah, I can do math. Unless I was wrong, then I can't. But it'll do precise scheduling. If you need something to happen immediately, you can do on-demand trigger. Say, do this job now, and we'll go off and do the job now. Oh, that's what the bullet point's for. I really like the separate job server concept, and I think I should have more slides dedicated to that concept in general, because a lot of this work you probably don't want to do on your main web application. You want to have it somewhere separate, because you want the web server to be the web server. I've already talked about that. Have a separate job server that does all the work. You can scale it independently. So if you need more job servers to handle load, you create more job servers. Couple cons. I don't like vendor lock to a degree. Using Quartz jobs, you're vendor locked. So unless you're abstracting out and the job is just calling into your own abstraction, you're locking in the Quartz. That's all right. And for most of us, for 99% of us, that's okay. It's not a big deal. I also don't like their process for tying into .NET dependency injection. Every other library in .NET has gotten that part right nowadays. Quartz hasn't. Quartz needs you to install a whole separate package, and you write a handful of lines of configuration. Every other library out there just works. But no big deal, but it's a small con to be worried about. All right, HangFire. I came to HangFire a very long time ago, and it's been in probably every application I've written for the past 10 years. That's probably a rough estimate. HangFire, all right, show of hands here. Who's not heard of HangFire? Not heard of HangFire. All right, more than Quartz. So more people have heard of Quartz. All right, I'm about to blow your minds. Probably not. But all right, Quartz or HangFire, same idea. We have jobs that run on either on demand or on some sort of schedule. And what's really cool about HangFire is you can add these fancy UIs to your web apps so you can track the jobs being done. This is most synonymous. Any Rails developers in here? No, not a single Rails developer. Awesome. Disregard anything I'm about to say. So Rails have this system called Sidekick. And it's like one guy wrote this application and makes $10 million a month on it. And it does what HangFire does. And I'm super jealous of him. But HangFire is, for .NET, what Sidekick is to Rails. And it's just a job runner with a fancy UI. And it does all this really cool stuff. We'll see that part in a moment. The implementation is your own code. If you write a class, notice there's no I of anything. There's no implementing an abstract class. It's just clean up temp folder job. This is my own code. It's my own methods. Then, when I configure HangFire, we see I have a line here that says reoccurring job. I'm telling it to add or update an existing job if it's already there. That I want to go execute my class called execute, or my method called execute, every 30 seconds. Or down in, I guess it's easier to point. I can't really point here, can I? Yes, I can. Can I do this? No, I'm not going to do that. Inside my map get, I have a call to generate. And that schedules a call later for the generate method. So I'm telling HangFire, these are the things I want to go run. These are all my own classes. It's using the strengths of C# and generics and all that good stuff to say, all right, give me your types, and I'll execute the methods on your own types. There's nothing special to implement elsewhere. This will make more sense in code. So let's jump over to our HangFire program. There's a whole bunch of stuff in here, but let's just talk about the important pieces. So I have a temp job class, again, not implementing anything. I'm using .NET dependency injection. Now I have these two methods, execute and generate. And these are my own methods. I could call them foo, I could call them bar, I can call them Steve, I can call them whatever I want to. It doesn't matter. And from these two methods, the only thing that's required is that they're public. So HangFire can access them later. They could be asynchronous if I need them to be asynchronous. Then, from various parts of my application, I can inject what's called the background job client. And the background job client is just my connection to HangFire. And I tell it, all right, please go run the temp folder job for me. And it'll go do that. Or, I'm sorry, the generate. Or here's a schedule example. So maybe I don't want to do it now. Maybe I want to do it in 15 seconds or a couple hours from now. I can schedule jobs that happen at a later time. I also have this concept of the dashboard. So if I want the fancy UI for HangFire, I just add one line of code. I now have a fancy UI. If we run this, .NET run, one thing you might notice here at the top, it's installing SQL Server objects. The piece I left out at the beginning is that you have to have some sort of backing store for HangFire to persist over time. By default, that's expected to be SQL Server. SQL Server is great. There's a couple caveats with SQL Server, but it works well enough. You could also use any relational database. In my course, I use SQLite, I use MySQL, and SQL Server. They all work well. You could also use Redis if you're willing to pay for it. That's really smart of the HangFire folks because they pay for the better data store. But SQL Server works well enough. So it automatically installs itself into SQL Server if you give it a connection string. And you see here it's running a reoccurring job. But I'm going to open my Edge. Let me find my browser. And by default, you go to /HangFire. This brings up the HangFire UI. I'm going to blow this up a little. Now, a couple things of interest here. You have the jobs that have run. You see here's every job that's run on my application. And it tells you when it ran, how long it took to run, and whether or not it was successful. We can also have failures if there were failures. But my code doesn't crash, so it's not a problem. Hey, I got a couple checks. We can get a full, basically, job log of any job that's running at the time. So here I see that the job was queued. I can have various named queues with different priorities. When was it processed? How long did it take to process? Did it succeed or fail? If it fails for any reason, it'll automatically retry up to 10 times, and it'll tell me every time it's retried. Even better, up here at the top, it tells you the call that was made to execute the method. So if I have parameters, so execute might take 3 or 4 parameters if it did. It would show me all the parameters and would tell me what the values of those parameters were at the time the job was called. I can switch over to reoccurring tasks. So this is everything that's going to run on some sort of schedule every 30 seconds. When was the last time it was executed? When's it going to execute again? I'm cheating it a little bit because I created this demo 4 months ago, and I forgot to delete the database. But I could run these on demand too. If I need this to run now, it's run. We had an issue the other day with one of our applications. One of the guys on my team did a deploy, and he broke one of the HangFire jobs. And we didn't know about it until the next morning, so we had 80 failed jobs, which doesn't seem like a big number, but to the customers that we affected, it was a big number. So we were able to actually go in, push our fix, go back, and rerun all the failed jobs, and it was like nothing ever happened. Doing that in any of our other services would have been a pain in the butt. HangFire made it very easy. We can also have multiple servers. At any one time, I'm probably running 3 or 4 different servers, just job workers for heavy lifting. We can also prioritize stuff, but I'm not going to talk about all that right now. Let me show you what it's actually doing. So I think it's cleanup temp folder job. Now I have a handy little method here called generate. No, it's not generate. What is it? Oh, generate now, generate later. Yeah. So we're going to say generate now. Now this is going to go off and probably run very quickly. And there's a whole bunch of files in here. I think I tell it to generate 100 files. And we're going to wait a moment. Let's put these side by side. Oh, I was too slow. It deleted all the files. So that's one way to do it. I could also say generate later. Now this is going to schedule a job. So we see generate, the same method, just running at a different time. It's going to run in a few seconds. We can go look at it. It's in queued. There we go. So it ran, succeeded, and actually, it ran and immediately the cleanup job ran after it. So, yay, it's working as intended. But this is really useful if you like having the UI, knowing when these jobs run, being able to go back and look at the history of jobs when they run. Very useful for all those use cases. We have used HangFire heavily in a lot of our applications. That's why I like talking about it here. There are a couple pros and cons to it, though. You get that precise scheduling and timing like you did with Quartz. So if it doesn't run when it's supposed to, it's going to catch up as soon as it can. It's much easier to run one-off jobs when you need them to. I also like that our jobs are strongly typed. We're not beholden to Quartz and their particular implementation of a job. We can write our code or bring in our existing code and just add it to HangFire, and it works exactly the way that we want it to. The UI is amazing to have a UI. The UI is not amazing because it's Bootstrap. That did not get a laugh. Okay, I'm sorry. I offended Bootstrap people. The big con is that you have to use SQL Server or some sort of relational database behind the scenes. If you want the really good performant paywall or data store, it's behind a paywall, which I don't think is a huge con because we've architected around the issues with SQL Server. And most of the big issues have been around HangFire had a bug once, a couple of years ago. It's been fixed, where it would use 100% utilization on SQL Server, and we were running on SQL Azure, and it actually took down our production database because, or took down our production system because we had two systems both talking to the same database. And yeah, that was a fun afternoon. What we ended up doing was just using a different database just for HangFire jobs, and it solved all of our problems. We did set up a separate job server for HangFire, which I think is, because it's strongly typed to your code, means when you make a signature change or add a new method that you need to use in HangFire, you have to deploy everywhere, not to just usually the one place that you would normally care about. Again, not a big problem, especially if you have some sort of continuous integration in place, but something to be aware of. That's why I have a course on it. I'm actually building courses on all the different tactics. HangFire was first because it's my favorite. But again, I'll make sure that this is in Slack at the very end. I'll wait for the cameras. Again, you all get it for free. All the cameras come up. All right. Let's talk about the last tactic. And so the story with this is we were heavily invested in HangFire. And then we hit this point where we were asking our HangFire to do too much. And it was actually becoming more cumbersome to write our background tasks for HangFire than it would be. And we needed more scale. Like, it wasn't a big deal with HangFire to process like 100, 200 entities. You just create those jobs and it goes off. But we were starting to hit workflows where we needed to process 4 million entities. And HangFire could do it, but we were really hitting that wall of we needed more processing power, and what we really needed was cloud scale. So we were deploying all of our stuff to Azure. We had taken a look at using Azure Services to do a lot of this work for us. And I used to be in the boat of, serverless is not serverless. It's someone else's servers. I'm just borrowing it. And if you're out there and you're nodding your head, you probably agree with me. It's like serverless is just a fad. Serverless changed. Something clicked in me, and I radically changed my opinion of serverless, and I want to use it for all the things now. It is my new hammer. So what's really cool about Azure Functions, and this is not a serverless talk, it's just talking about Azure Functions in general, is that I can take the same concepts for background tasks. So I have things that need to happen immediately. I need to happen on some sort of schedule, or I need them to happen when some sort of event occurs. Azure Functions is basically that as a platform, where I have something I need to run on some sort of timer, or some sort of schedule. And if I'm using cron, I could say every 30 seconds, I need something to execute. Well, this is really cool. This is going to do the exact same thing I was doing in HangFire or in Quartz, etc., except it's in Azure Functions, and it's scalable. So if I need to scale this out across 20 different nodes, it'll do that for me automatically. And I have way more options in terms of triggers than I did with stuff like HangFire. This is meant to be unreadable because it's a very long list. So if I want to listen for changes in my blob storage, I could do that and automatically execute some code. If let's go down the list. I'm listening to a queue, and I need to process stuff as they get populated into a queue, I can do that. If I care about timers, if I'm looking at table storage or a RabbitMQ, there's triggers for all kinds of different services. And you can also write your own triggers. So if you have your own services and you want to write jobs that run when certain events occur, you can write your own trigger. There's a new one for SQL Server. If you want to execute an Azure function when a table row gets updated or inserted, automatically runs an Azure function. And that's crazy powerful in my opinion. So let's go look at a very basic Azure function. And then we'll wrap up for any questions you all might have. So this one's very simple. It's a timer trigger. It's not cleaning up anything because that was way harder to do in Azure Functions. And what this is doing is every 30 seconds, it's going to go to the web, and it's going to get a list of articles on my website. It's going to pull them down, and it's going to drop them into a blob for me. So nothing special. Let's open up the blob. Let's delete what's already in there. We'll say, this is a different command. This is func start. Now I have another talk I did. Didn't get it selected by NDC, but it's called Annihilating Workloads with Azure Functions. And we show a use case where we have 4 million entities that if we just had a standard process, like a for each loop going through them, it would take hours and hours and hours to process all these different entities. If I had a multi-core system that was processing the same loop parallel, it would still take a couple hours to do all this work. But we drop into an Azure function, and we populate a queue with the same workload, it knocks it out in 30 seconds. I am very much an advocate for cloud scale and power here. So I had a timer trigger, so a background task to run every 30 seconds. And you can see it goes off and executes an HTTP request. And we could see, oh, I got the file, and then I'm not going to bother opening the file, just showing you that it's happening every 30 seconds like we expect it to. And I could have triggers for a variety of other processes, and they all work the exact same way. So again, the pros and cons. Again, precise scheduling and timing. Actually, even more so. There's a concept in Azure Functions timers. It's basically if the timer doesn't execute when it's supposed to, it's immediately going to try, it's going to catch up when it can. And it'll tell you, I'm running the timer out of sync, but it's because it never ran previously. And if your timer trigger fails for any reason, it's going to automatically come back and retry the trigger again. There's dozens of trigger options out there, ways to execute code when things happen. And that's kind of the whole point here, is when something happens, whether it's a certain time elapses or an event occurs, I need to go do some work. The biggest benefit of Azure Functions is I get cloud scale. So if I need to do a lot of work at a moment's notice, I have the cloud available to me. But when I don't need that resource, it's not something I'm using, it's not something I'm paying for, it just kind of goes away. So I can scale up and down as gracefully as I need to. The tasks are independently resilient. So if I have a timer trigger, or if I have some other sort of job, like a queue trigger, if it fails for any reason, it's automatically going to retry to run the job again. And it's going to retry a certain number of times, and then it fails, but it fails in a way where I can detect the failure and go see what the issue might be, retry the payload if I want to. The biggest con, and this is the biggest con, is that there's an Azure requirement. So if you're on AWS, you got Lambda, and I'm only like 3% aware of what's in Lambda. I'm an Azure guy, but there are other serverless platforms out there that do very similar things. So whether or not you're using Azure, yay. But if you're using something else, there's probably a way that you can solve the same problem. The biggest conclusion from all this is just make sure you're doing work in the background. If you have anything that's heavy lifting, you need to do a lot of it. Don't do this on anything that might potentially affect the user or the customer. So don't give them that error page that something went wrong when it was something that should have been done in the background to begin with. The user experience should be pretty straightforward. Click the button, something happens. Click the button, something happens. If there's an issue that's going to occur, let it occur somewhere else, somewhere that we can control what happens. The user, even if it fails, the user should still get a thumbs up and that positive experience, unless it's something that they need to fix immediately. But all that said, I'm going to hang out for a couple minutes and then clear out for the next speaker. I am happy to answer any questions you have. Thank you all so much. Mm.